Good morning. Today is Monday, and I'm actually filming this on Sunday so that I have time to upload it onto YouTube and then get it on to Schoology for you guys Monday morning. So since it's Sunday, my thought of the day is Happy Palm Sunday. All right, so we're going to do the last day of trig notes, and the very last topic in trig is called DeMoivre's theorem, and DeMoivre's theorem is used to raise a complex number to a power. Remember that we have binomial expansion, and that's another way to raise any binomial to any power. But DeMoivre's theorem is used more often in calculus, so this is a real important concept that you guys will need moving forward into Calc 1 or into AP Calculus next year. So if z, our complex number, is r times the cosine of theta plus I times the sine of theta, if you're going to raise that complex number to a power, say z is going to get raised to the n power. The way that you do this is you take the coefficient r, that gets raised to the n power, so whatever exponent you're raising your complex number to, you raise the coefficient r to that power, and then you multiply the angles by the power that you're raising it to. So it would be the cosine of n times theta plus I times the sine of n times theta. I don't think this is very difficult to do. If you've understood the notes so far on trig form of a complex number, product and quotient of trig form of a complex number, DeMoivre's theorem is not any more difficult than that. All right, so let's get into some examples. For example number 1, z is going to be equal to 2 times the cosine of pi over 6, 2 times the cosine of pi over 6, plus I times the sine of pi over 6. Now, I mentioned this in one of the earlier videos, I don't remember which day it was, but when you're writing the trig form of the complex number or a trig form of a complex number, these angle thetas always have to be the same. So what we need to do here is we have to find z cubed. All right, so you take the coefficient which is 2, raise it to that power, so it's going to be 2 cubed times the cosine of, and you multiply the angles by the power you're raising the complex number to. So it's going to be 3 times pi over 6. It's 3 because we're cubing it, plus I times the sine. And like I said with product and quotient of trig form of a complex number, what I would like you guys to do is write down what you're going to do here, and then for the sine, actually do the arithmetic. And when you multiply 3 times pi over 6 and you cross cancel, you get pi over 2. All right, now remember that pi over 2 is right up here on the unit circle. The coordinates there are 0, 1. So z cubed will be equal to 2 cubed, which is 8. The cosine of pi over 2 is 0. The sine is 1. Don't drop the I. Distribute the 8. Z cubed is equal to 0 plus 8i. Now, you absolutely need the 0 in there because a complex number is a binomial, a plus bi. So you can't answer just 8i, you need the 0 also. For example number 2, we're going to find 3 times the cosine of pi over 3 plus I times the sine of pi over 3. This whole complex number we're going to raise to the 4th power. Okay, so you take the coefficient, which is 3, r is 3. That's going to get raised to the 4th power. Multiply the angles by the power that you're raising it to. Cosine of 4 times pi over 3 plus I times the sine. Multiply, you get 4 pi over 3. 3 to the 4th power is 81. go to your unit circle. My unit circle is over here. I'm going to find 4 pi over 3. 4 pi over 3 is in quadrant 3. The coordinates are -1/2, negative radical 3 over 2. So the cosine is -1/2. The sine is negative radical 3 over 2. Don't drop the I. Distribute the 81. So the answer is going to be -81 over 2 minus 81 radical 3 over 2i. Now this 81 radical 3 over 2i, if you want, you could have written it as 81i radical 3 over 2. Just don't put the I underneath the radical sign. For example number 3, the directions say use the trig form of a complex number to evaluate -1 plus I cubed. So we have -1 plus I cubed. And because the directions say to use trig form to do this, first we have to take this a plus bi complex number and put it into trig form. So this is a review of 2 days ago, trig form of a complex number. This is going to be your x plus yi, or a plus bi. Because x is negative and y is positive, we would have this triangle in quadrant 2. Right angle is at the x-axis, theta is at the origin. Your x value is a -1. Your yi value is a +1. X-axis, y-axis. If you remember from Regents geometry, your isosceles right triangles, or your 45, 45, 90 right triangle, the relationship of your sides in a 45, 45, 90 right triangle are x, x, x radical 2. So it would be 1, 1, 1 radical 2. So r here is the square root of 2. Now if you don't remember that from Regents geometry, you can absolutely use the Pythagorean theorem to find the hypotenuse. Remember your r value, your hypotenuse is always positive. Now we have to find the rotation. Use tangent, because you always want to go back to your givens. Tangent of theta is equal to opposite over adjacent. Tangent of theta, our opposite is a -1, our adjacent is a +1. Whoops, I've got that backwards. It's +1 over a -1, which is still equal to a -1. Our theta prime in quadrant 1 is inverse tan. Remember, this is going back a couple of trig chapters ago. You always make this positive because everything is positive in quadrant 1. In quadrant 1, tangent is equal to +1 right in the middle of quadrant 1 at pi over 4. Now we have to take that pi over 4 and put it into quadrant 2 because our triangle is in quadrant 2. So the theta that we're going to use to do this question, if you take pi over 4 and you reflect it into quadrant 2, it's 3 pi over 4. Okay, the formula for trig form of a complex number, z is equal to r times the cosine of theta plus I times the sine of theta. So the trig form of the complex number -1 plus I, r is the square root of 2, and then our theta, once we rotated it into quadrant 2, is 3 pi over 4. So it's going to be the cosine of 3 pi over 4 plus I times the sine of 3 pi over 4. So that's not raising it to the third power yet. All of this lead-up work is just putting it into trig form. But what we need to evaluate is this complex number cubed. So z cubed would be equal to the square root of 2 cubed times the cosine of 3 times 3 pi over 4 plus I times the sine of 9 pi over 4. Okay, so now there's a couple of things going on here. When you cube the square root of 2, what's going on is it's the square root of 2 times the square root of 2 times the square root of 2. You multiply what's underneath the radical sign, so that's going to be the square root of 8. 9 pi over 4 is more than a full rotation on a unit circle. It's more than 2 pi. So if I take my 9 pi over 4 and subtract off 2 pi, a full rotation, 2 pi would be 8 pi over 4. 9 pi over 4, the coterminal angle to that would be pi over 4. So this will be z cubed is equal to the square root of 8 times the cosine of pi over 4 plus I times the sine of pi over 4. Z cubed will be equal to the square root of 8. The cosine of pi over 4 is positive radical 2 over 2. The sine is also positive radical 2 over 2. Don't drop the I. When you distribute the 8, this is radical 8 over 1, so z cubed is equal to the square root of 16 over 2. The square root of 8 times the square root of 2 is the square root of 16, plus the square root of 16 over 2i. I don't need that. So z cubed will be equal to, the square root of 16 is 4, 4 divided by 2 is 2 plus 2i. I'm not going to run through the last example, but please look at it on my notes from Schoology. I'm just going to talk to you about it for a second. 3 minus 4i, the x value is positive 3, the yi value is a negative 4. This is a 3, 4, 5 right triangle, so r is going to be 5. When you do the tangent function, you're going to get tangent is 4/3. It's not a value we know from the unit circle. So go to your calculator. You're going to get a theta prime of 53.130 degrees. To put that into quadrant 4, you would do 360 minus that. That gives you your angle in quadrant 4. So write your trig form of your complex number out, and then follow the notes from the first 3 examples about raising that to the 5th power. So this finishes up all of the trig notes for the course. Over the next few days, I'm going to have you take a trig test. It's going to be based on whether or not you do it, not how correct it is. So it's going to be an effort-based test that you're going to have to upload pieces of the test. On Tuesday, Wednesday, and Thursday, we're not going to have school on Friday because that's Good Friday, and that would be a day that we would be off anyways. Next week, again, I have to continue instruction because it's a college course. Next week, I'm going to run through the conics chapter and do something every day with that. The week after, I'm going to start limits. And we're right on track to finish this course on time. So I hope you're all doing well. Have a wonderful day, and we'll talk again soon.